First problem I want to review is problem number 2. Problem number 2 is dividing with scientific notation. So we have 4 times 10 to the 8th power divided by 2 times 10 to the 15th power. And before I get too far into this problem, I want you to also remember that you could see this as 4 times 10 to the 8th power divided by 2 times 10 to the 15th power, where you will have to remember that you're dividing scientific notation. So I would suggest going ahead and rewriting it in fraction notation, because I think fraction notation is a bit easier to apply our rules to. And so our basic rule says to go ahead and simplify our leading term. 4 divided by 2 is 2 times, and then we simplify our base 10s. Since they have the same base, we're going to apply our quotient rule, which then says 8 minus 15, which is negative 7. Now we need to ask ourselves, is our solution in scientific notation? Our term in front of the multiplication sign is a value between 1 and 10. That's correct. And then we're multiplying by a base 10. So we do have a term in scientific notation. That would be correct. 2 times 10 to the negative 7th power. Now multiplying with scientific notation. Let's start out with our 3.11 times 10 to the 4th power. This is problem number 5. Is getting multiplied by 2 times 10 to the 7th power. Now we want to remember that we will be multiplying our decimal terms, or our terms in front of the multiplication sign. They can get multiplied together. So 3.11 times 2 gives us 6.22 times, again, we notice we have 2 of the same base. Since we have 2 of the same base, we can use our product rule, which says that we add the powers. 7 plus 4 is 11. Now we need again to check, is our solution in scientific notation? Is the term in front of the decimal place a value between 1 and 10? And it is. So we are done with that problem also. Number 7. Number 7 says 9.15 times 10 to the 4th minus 8.2 times 10 to the 3rd. Now, we talked about in class that in order to subtract with scientific notation, our base 10s need to have the same power. So we need our first term, 9.15 times 10 to the 4th, to be adjusted so that it has a 10 to the 3rd power. And we know that when we bring the decimal down, or sorry, the power down, that is a result of moving the decimal to the right one place. And so we end up with 91.5 times 10 to the 3rd minus 8.2 times 10 to the 3rd. Now, by way of review, I want to refresh your memory on why the shortcut works for subtracting with scientific notation. both of our terms are getting multiplied by 10 to the third power. So if you remember back to factoring, when you factor, you're pulling out a GCF, which is your greatest common factor. And our greatest common factor for both of these terms is 10 to the third power. So if I divide 91.5 times 10 to the third power by 10 to the third power, I'm left with 91.5. And the same with our expression on the right, we would be left with 8.2. Now we can simply follow our order of operations, which tells us to subtract 91.5 minus 8.2, and we end up with 83.3 times 10 to the third power. This isn't exactly scientific notation, so I'm going to take that 10 to the third power and move it to the end of the statement. And we end up with 83.3 times 10 to the third power. Now we are in the almost scientific notation stage. I need to move my decimal to the left one so that my leading term is a value between 1 and 10. And that will give me 8.33 times 10. Moving the decimal to the left causes my powers to increase by a value of 1. So 10 to the fourth power. Now, one more problem I want to do for you is problem number 13, because it's a little bit of a messy problem, but it's a good problem for you to see and be familiar with. So, problem number 13. It reads 2 to the 5th, a to the 5th, over 2f to the 5th, plus 2 to the negative first, f to the negative first, a squared, f to the negative first, over a to the negative third, f to the third. So we can tell there's quite a bit of movement that needs to happen in this particular problem. For right now, I'm going to leave the term on the left alone. 2 to the 5th, a to the 5th, over 2f to the 5th. And I'm going to do that because I know something about how this is going to simplify, and it's going to save you a step to leave it alone. You could simplify it down, but you'll understand once we work through this problem a bit of the way why I don't. So let's work with the term on the right. I see that I have a negative first exponent on my 2, so that's going to bring it down into the denominator. I'll go ahead and cross that off so we know we used it. I see an f to the negative first, so that's going to bring it down to the denominator, f to the first power. A is to the second power, so it's going to stay in the numerator. F to the negative first is going to come down to the denominator. And that cleans up all of my terms that I originally had in the numerator. So now I'm going to look down to my denominator. I have a to the negative third. It's going to come upstairs. And f to the third, it's going to remain in the denominator. So we can see that I can clean this up a bit. So 2 to the 5th, a to the 5th, over 2f to the 5th, plus a to the 5th, over 2f to the 5th. And at this point, you understand now why I left my first term alone. Because it had 2f to the 5th, and I already knew that the term on the right was going to simplify down to 2f to the 5th. If you did go ahead and pre-simplify the term on the left, you would have ended up with 2 to the 4th, a to the 5th, over f to the 5th, which is fine because our basic concept of adding fractions would be that we have common denominators. And your process for getting a common denominator would be to multiply your term on the left by 2 in both the numerator and the denominator. And that's going to give you exactly what we currently have. So we can add this fraction together, and we end up with 2 to the 5th, a to the 5th, plus a to the 5th, over 2f to the 5th. And so we need to look at what we can clean up here. Well, 2 to the 5th is the same as saying 32 a to the 5th plus a to the 5th over 2f to the 5th. And now we recognize from our numerator that we have 32a to the 5th plus a to the 5th. So those are now like terms. We can add them together. 32 plus 1 is 33. A to the 5th over 2f to the 5th. At this point, there's nothing that will simplify without giving me decimals, which we're not really interested in having. We want to have whole terms as much as possible. And so our solution would be 33a to the 5th, 2f to the 5th.